Someone is currently building a massive AI compute cluster, 300 miles from the most contested shipping lane on Earth. This project sits directly in the path of a significant geopolitical event. A midnight EDT ultimatum now threatens strikes on regional power plants and bridges if a ceasefire is not reached. The targets involve dense urban infrastructure and regional petrochemical complexes, places where drones have already ignited fires in recent days. Because this region moves 20% of the global oil supply, the market reaction was immediate. Futures dropped, oil spiked, and investor sentiment entered a state of extreme fear. Despite the headlines, the people who actually move goods are staying focused. Logistics coordinators are methodically rerouting their fleets, tracing new paths on their displays to keep the supply chain in motion. These geopolitical shocks act as live stress tests for our physical infrastructure. They trigger specific resilience protocols that allow the system to adapt rather than fail. While the markets fluctuate, the alliance between Anthropic, Google, and Broadcom is moving forward with a massive expansion of physical AI hardware. This deal targets multiple gigawatts of next-generation compute capacity, specifically designed to train the next tier of frontier models. To visualize that scale, 1 gigawatt is roughly the total electricity required to power a mid-sized city. This alliance is essentially building several cities' worth of continuous electrical load. Builders are accelerating these projects now because frontier AI depends on physical reality. These facilities take years to plan and permit, and waiting for a period of global stability would put their long-term roadmaps at risk. The commitment of billions of dollars to permanent steel and silicon suggests a clear bet on the future. These builders are operating with the conviction that technological abundance will eventually outpace today's instability. Rapidly scaling hardware creates a new engineering requirement. As models become more powerful, the systems used to align them must keep pace to ensure the final output remains reliable. OpenAI is addressing this through a new safety fellowship. The program funds a global network of researchers to focus exclusively on the technical challenges of model alignment. This parallel growth is intentional, treating AI safety as a rigorous engineering discipline, receiving the same capital and focus as raw compute. Researchers integrate automated real-time error-checking guardrails directly into the training process, allowing models to self-correct and stay within intended parameters. Safety engineering provides the directional control necessary for high-speed scaling. It functions like a steering mechanism, giving the system the stability it needs to handle massive increases in raw power. We are seeing a convergence of fields. The specialists managing gigawatt-scale energy grids are now working side by side with the safety auditors to deploy these systems. This massive infrastructure drive is creating a surplus of accessible intelligence. As the cost of running complex AI models drops, the ability to build sophisticated tools moves from the lab into the hands of individual creators. You can see this shift in tools like Blink.new. It leverages that background compute power to turn plain language descriptions into fully functioning software. By typing a simple request, like a fitness app with a custom dashboard, the system generates the full stack code and the user interface instantly. You review the build and hit deploy. The same pressures that are forcing our infrastructure to become more resilient are also making our tools more powerful. This entire system exists to amplify what you are capable of doing. So the real question is, what are you going to build with it?